We are going to look at problem 1 from our hypothesis test section and complete a formal hypothesis test on this example. Some boxes of a certain cereal brand of breakfast cereal include a voucher for a free video rental inside the box. The company that makes the cereal claims that a voucher can be found in 20% of the boxes. However, based on their experiences eating the cereal at home, a group of students believes that the proportion of boxes with vouchers is less than 0.2. This group of students purchased 65 boxes of cereal to investigate the company's claim. The students found that a total of 6 vouchers for free video rentals in the 65 boxes. Suppose that it is reasonable to assume that the 65 boxes purchased by the students are a random sample of all boxes of this cereal. Based on this sample, is there support for the students' belief that the proportion of boxes with vouchers is less than 0.2? Provide statistical evidence to support your answer. We are going to use the hypothesis test template to complete this. First, you must name the test. This is a one-sample test for proportion. It's also known as a one proportion z-test on your calculator. So we need to state our null and alternative hypothesis. In order to do that, we need to define our parameter. And our parameter is going to be p, since it's a proportion. And it's the proportion of cereal boxes that contain a movie voucher. So our null hypothesis would be p equals 0.2. Our alternative hypothesis, our competing claim, is that p is less than 0.2. And the evidence for our alternative hypothesis is p hat, the sample the students found. 6 divided by 65, which is about 0.092, which is less than 0.2. You still have to check your conditions. And our first condition about a random sample, we were told to assume the 65 cereal boxes come from a random sample. And our 65 boxes is less than 10% of all cereal boxes. And n times p would equal 65 times 0.2, which is 13, and that is greater than 10. And n times q equals 65 times 0.8, which is 52, which is also greater than 10. So our sample size is large enough. Now we must go through the mechanics. So with this problem, we were not given a significance level, so we're going to use an alpha of 0.5. And we need to find our standardized statistic z, and the formula for that is p hat minus p all over the square root of p times Q divided by N. So we go ahead and we plug in our p hat, which is 0.092 minus 0.2, all over the square root of 0.2 times 0.8 divided by 65. So you can go ahead and put this in your calculator, but we're also going to run the test of significance. And the calculator steps are: 1, you're going to go to the stat key and choose test and number 5, 1 proportion z-test. Then step 2 is you're going to put in your proportion, 0.2, your number of successes from your sample, which was 6 cereal boxes had a voucher, out of our total number of cereal boxes, which was 65. Since our alternative hypothesis is less than, because our compete and claim is that less than 20% of the cereal boxes have vouchers, we would choose less than. And then here you would choose calculate. That blinks on and off, so right now it's black. When you press calculate, we'll get our 1 proportion z-test for when our compete and claim is less than 0.2. It gives us our z-value of negative 2.17. Our p-value, which is 0.01498, and our p hat of 0.092. And it gives us our N of 65. And we found that using our calculator, but you can also find it using it here. So our Z, our standardized score, is negative 2.17. So what this means is if I were to draw this, my proportion would be here. Negative 2.17 would be out here, okay? And then it also, if we look at this, gives us a p-value. So right here, we have our p-value, okay? Our p-value is 0.01498. And that's the area underneath here. And what this means is the likelihood of getting a sample result in that extreme result in the extreme is given if our null hypothesis is true, okay? So what we're going to do is we're going to make a decision and a conclusion about this. So you're going to compare your p-value to alpha. And here, when I look at this, I have my p-value here and my alpha level here. So my p-value is less than alpha. So 0.01498 is less than 0.05. Since my p-value is lower than my commonly used significance level, we would reject the null hypothesis. And the sample does provide evidence to suggest that the company is cheating.